Hey everyone, and welcome to Dr. Abu RTN Academic channel. Today we are going to discuss part 2 of seminar number 4 of the University of Debrecen and the Biostatistics subjects, and in this video we are going to discuss the solved examples. See, here we'll start with the first example, which some of the students will be a little confusing because we said to use the binomial or Poisson distribution. We need to have two options only, okay? The possibility should be two things, happening or not happening. So here it says that we roll a fair dice 5 times, okay? So n equals 5. We rolled it 5 times. The number of trials, number of experiments 5 times, and record the number of the dots appeared on the up face of the dice. The number will appear on the up face. It could be 1, 2, 3, 4, or 5, or 6. Someone will say, okay, so there are 6 possibilities. Why we are saying that we can use Bernoulli's distribution here? It should be either tail or head, only one of the possibility. No, but here only one thing will appear on the top face. He asks us here, what is the probability that 6 dots is not a number. This is the face which he has here, the 6 dots. Okay, so this face. What is the probability of this face, regardless of 6 dots or 2 dots or what? This face appearing, okay? What is the probability of this face appear on the top, occur exactly 3 times? So the possibility here that this face either will appear or not appear. So there are 2 choices only. This face, regardless of what's called 6 dots, 2 dots, 1 dots, whatever you call it, this face will appear or not appear. So there are two options only, 2 possibilities only. It will occur or any other face will occur. So it will occur or not occur, okay? So it is still 2 options. So he wanted to occur 3 times. When I have the number of happening and the number of repetition, okay, how many times it will occur, so I come to know that it might be Bernoulli's distribution. But I have some other thing which I have to check. Are they independent? What does it mean independent? So if the face of 6 appear first time, can it be appeared second time or third time, or the first appearance will affect the next appearance? It will not affect them. So let us go as per the solution which is given here to save our time. So the binomial distribution has to be used. Someone will say because it has 6 sides, so it could be 1, 2, 3, 4, 5, 6. Since there are 2 outcomes only, either 6 or any other face, either face of 6 dots or not 6 dots. 6 dots. The number 6 doesn't matter for me. It's just the name of the face, okay? One of these 2 options, okay? And the experiment is independently repeated 5 times. So every time any number can appear. If 6 appears first time, it can appear next time. If the 5 appear first time, it can appear second time. So they are independently appear, okay? The number of the elements in this case will be n, as we rightly mentioned here, okay? Because he has to repeat the experiment or the test or the number of trials 5 times, so n equals 5. If this considered to be Bernoulli's process, okay, the probability of one of the outcome, what? This is one face. 6 is one face out of 6 faces. So the reason he gave us the dice to know the probability, because he don't want to give us the probability 0.1 or 0.16 or 0.2. So he gave us one face out of 6 faces. So what is the probability of this face will appear of 6 dots? The probability 1 over 6, which equals 0.16666 or 167, okay? This is the probability. So what will be the Q? Q equals 1 minus P, right? It will be equaling what? 0.833, okay? So let us write it here on the side. So here P equal 0.67, Q equals 0.833. Okay, so I have got this 3 criteria. So I have now, I'm looking for K. How many times he want to repeat it? He said if they repeat it exactly 3 times, okay? Comes on the face occur exactly 3 times. So K equals 3 times. So I have now all the required 4 criteria for Bernoulli. So what is Bernoulli? Bernoulli say the probability of K appearing 3 times equals, what we called it? We called it NCK. You remember NCK? Okay, if you forget the formula, okay? So NCK means, just erase this one, equals NCK, okay, P of power, the last one, Q, AK, Q of the power N minus K, N minus K. Then let us substitute, so it will be N factorial divided N minus K factorial, okay, K factorial, this is NCK, times P of power Q, P of power K, P of power K, Q of power N minus K, N minus K, okay? So I have to just substitute in this one. So let me substitute. N factorials, N equals 5, so 5 factorial. N minus K, K is 3, and N is 5, so 2 factorial. K, 3 factorial. P of power, what is P? P is 0.17167 of power K, which is 3. Q factorial, which is 0.833, okay, of power N minus K, which is 2. So I can get them on the calculator, okay? So here for this one, I can extend it. Instead of having 5, it will be 5 times 4 times 3 factorial. So 3 factorial will cancel with the 3 factorial. 4 times 5 equal 20. 20 times 2 equal 10. So this will be equaling to 10, okay? Okay, so 10 times these two numbers, you get them on the calculator. You will find the answer is 0.03215. So this is the probability of the phase of the 6 dots appears 3 times. Okay, I hope this one is clear and just an application on Bernoulli's distribution, so it will fix it in our mind. Okay, here the example says a quiz consists of 5 multiple choice questions. So the total number of questions or trials which I have is 5. Okay, but these 5 questions are multiple choice question, okay? MCQ. So 5 questions, N equals 5. Each with 4 possible answers. So each question, it has 4 possible answers, which almost will be K, but let us complete the question and we'll come to show you that it is K. Okay, the answer could be A or B or C or D. Okay, one of which is correct. So 1 of 4 will be correct. Only one of them. There are no multiple choices or more than one correct answer. Okay, so every time in every question, one of them will be correct. So the probability of having correct answer is 1 over 4. Right? This is the probability, which is 0.25. So 1 in each 4 will be correct, and the 3 will be wrong. Okay. 1 of which is correct. Suppose that an unprepared student doesn't read any question. I hope that you are not the students. My students are very smart students and they're studying well. So I hope that you are not the student. So suppose that unprepared student doesn't read the question but simply makes one random guess of each question. What is the probability that the students will get all the 5? I hope that all of you will get the 5 answer, but with understanding, not by guess only, okay? That the students will get all the 5 questions correct, okay? So the question here, I have 5 questions, N equals 5, okay? The number of times, okay, the number of times, or first, the probability of the answer being right, I have four possibilities in each question. So each one of them will have one equal chance if I choose them randomly. So the probability of getting the right answer will be 1 over 4, which is 0.25. Okay. Then how many times I have to repeat these trials? So I have 5 questions. Okay. And the probability of getting the right answer is 0.25. So how many times I have to repeat this process? I have to repeat this process for every question. So the K which I assumed here earlier it is not right. So I should not from the beginning decide which one is K, okay? So I have to read the full question. That's why I put it here. So N, I have 5 questions. The probability of having the right answer, choose one of these 4, it will be 1 over 4, 0.25. So how many times I have to repeat this? He may said, okay, how many times the student get 3 answers correctly? 3 answers correctly. So K will be 3. 2 answers correctly, so K will be 2. But if he said 5 answers, all of them correctly, all the 5, so I have to repeat it 5 times and get all of them correctly. So K in this case will be equals 5. But if he said 2 questions correct, so I have K will be 2. 3 questions correct, the K will be 3, and so on. Okay, so I hope this clear how to get N, P, and K. Can I? Okay, so I have just wrote the formula here. So it will be n factorial, which is 5 factorial, n minus k, which is 5 minus 5 equals 0. Okay, don't need to write this one, okay, now because we have the formula already. 5 minus 5 equals 0. Okay, then k equals 5 also, 5 factorial, times p of power what? P of power k is 5, q of power n minus k, n 5, and the k 5, so 0, it will power 0. Anything of power 0 equals 1, okay? And 0 factorial equals 1, so the answer will be 5 factorial. Cancel this 5 factorial with 5 factorial, and 0 factorial equals 1, okay? So 5 factorial divided 5 factorials equals 1. P equals what? P equals 0.25 of power 5. So this will cancel with this, so it will be just 0.25 of power 5. So it will be equal 0.00097. This is the probability. Someone will say we have taken this in the combination area. What is the difference between this and the combination? This is the probability. This is not the number of ways. Permutation and the combination, we were giving the number of ways, but here we are given the probability. Okay, we're given the probability. So the probability of this student getting all the answer correctly without studying anything is 0.097. Even it is percent, even it is less than 0.1%. Okay, it is very less probability. It is totally unlikely. So I hope that no one of us will try this way. Okay, we have to study and answer it well based on our understanding. So in this example number 3, what it says, 80% of the population are immune. So if they give you the population and the percentage of the population, so it is likely will be the probability of the population. Okay, because for the population we're using percentages because we cannot, it is not a sample. Okay, we cannot calculate it, so it has to be measured or assessed by somehow. So I have 80% of the population are immune. Okay, so the probability here would be 0.8 for the population, okay, that they will not get this disease because they're already immune from the disease. This is the probability they will not get the disease, okay? Probability of negative will not get the disease. If random sample of 10, so n, the number of people, 10 people is withdrawn from the population, what is the probability that exactly 6 people will immune from the disease? So he wanted to be repeated 6 times. The first one immune, the second one immune, the third one immune. So 6 times. This is the repetition that the people will be found immune 6 times. So we say what is the probability that exactly 6 will be immune? So K, the number of repetition or occurrence, how many times it will occur that we will find them immune 6 times. So K equals 6 times, and then equals 10 times, and probability equals, so QA will be equaling 1 minus 0.8, 1 minus 0.8 equals 0.2. So I have all the criteria. I can write here P when k equals 6 equals, okay, n factorial, which is nck, okay, n factorial n minus k factorial, okay, p of power k, okay, q of power n minus k. So n factorial here will be 10 factorial divided n minus k, n 10 minus 6, 4 factorial, k factorial, which is also 6 factorial, okay. Then p, what is p? P 0.8, okay, 0.8 of power 6, q, which is 0.2, n minus k, 6 minus 10 minus 6 equals 4, okay, and calculated them on the calculator, or this one, you can calculate them on the calculator, factorial, 10 factorial, and 4 factorial, and 6 factorial, or you can calculate them manually. Just if you expand this one, 10 factorial will be expanded to 10 times 9 times 8 times 7 times 6 factorial, then 6 factorial will be cancelled with the 6 factorial down, okay, and we'll have 4 factorial. You have to expand the 4 factorial as well. The same thing you can calculate on the calculator, but you have to be careful or put brackets when you have the numerator and denominator, okay. Let me erase what I have done here. Okay, the answer will be, in this case, if you calculate in the calculator, it will be 0.088. Okay, so this will be the probability that exactly 6 of them will be immune. Okay, so you have taken 10 people, 6 of them are immune, and this population 80% of them are immune. Okay, so this is the probability. If I want to get it as a percentage, I can multiply by 100, it will be 8.8%. Okay, this problem is similar to the previous ones, but there is only one trick here. So it said that suppose that 13% of certain population is diabetic, okay, so the probability is 13%, 0.13, q equals 0.87. So I have p and the q, okay. If random sample of 7 people, n equals 7, withdrawn from the population, find the probability how many are diabetes. So how many diabetes were reoccurred? He will ask me now the k. He will ask me how many, what is the probability of 2 of them, 1 of them, 0 of them, 7 of them. He will give me the number now. Will reoccur, that it will happen, it will occur. Okay, we said that k, how many number it will occur this event. So what is the probability that, oh, he didn't give number, he gave more than. The trick is here, more than 2 will be diabetes. More than 2, this means that k equals 2? No, equals 2, k greater than 2. K greater than 2 or equals? No, greater than only. He said more than, he did not say more than or equals to. So what does it mean? More than 2, so I have to have all the calculation, this calculation of n divided n factorial divided n minus 1 factorial, k factorial, okay, n minus k factorial, k factorial, p of power k, q of power n minus k. For this, I have to repeat it for more than 2, which is 3, for 3, for 4, 5, 6, 7, 8, 9, 10, 11, 12, up to infinity. So can I do this, that it is more than 2? I cannot calculate for this infinite number of possibility. So what can I do? I can work it the other way, like the case of the scenario of the at least or more than. So we have to be careful at this. More than 2, I cannot calculate more than 2. So I have to calculate the other way around. So I have to get the probability that he said more than 2. I said no, equal, not more than 2. It is 2, 1, and 0. The probability of these 3 cases, because the minimum number will be 0. It could happen once or could happen twice, and then anything other than 0 times or 1 time or 2 times, anything before the more than this, it will be greater than 2. Okay, but only 0, 1, and 2 are not greater than 2. So I calculate this and say the probability 1 minus the probability of this 3. So I get the probability of this 3, and I'll say minus. So the probability of this 3 is 0.1, for example. So the probability of not happening, it will be 1 minus 0.1. It will be 0.9. So I calculate the other way around. The probability he said more than 3, I say no, equals 2 or less than 2, because here he has given me, he did not say equal, so I have to use k equals 2 as well. Okay, it's not only 1 and 0. If he said equals, I'll calculate for 1 and 2, which is less than 2, 1 and 0. But in this case, he did not give equal, so I'll use 2, 1 and 0. I hope this one is clear. So how many times I have to do this calculation? I have to do it 3 times. I have to use first time k equals 2, second time k equals 1, third time k equals 0, and calculate for all of them, and then the answer, the probability of this, k equals 2, the probability of k equals 3, probability, I get the sum of the, add them up, okay? And they say, for example, I got the answer was 0.15, for example, so my answer will be 1 minus 0.15, which is 0.85, okay? So let us try. So what I have to use k here, k will not be greater than, I use all the k's which is less than or equal to k. Okay, I hope this one is clear. So I get the probability of k greater than 2 equals 1 minus, if you can see here, he did it in one step, that's why it will be a little confusing. He did it in one step. He said the probability 1 minus the probability of using k equals 0, okay, plus the probability of k equals 1, okay, plus the probability of k equals 2, he add them together, and he said 1 minus. But in this problem, he distributed the negative here, so he multiplied negative inside the bracket. He did not put bracket, okay? For me, it is better to calculate them separately, so the probability, I say the probability of k equals 2 equals, what is the n? n 7 factorial, divided what? Divided 2, because the probability here, n minus k. So if I put k equals 2, so n minus 2, 5 factorial, times k factorial, which is 2 factorial, okay, p, which is p is 0.13, okay, of power k equals, in this case, 2, q is 0.87 of power n minus k, k is 2 and then is 7, so 5. So the first time, then get the probability of k equals, calculated, equals 1. The probability of k equals 0, okay, and so on. So here 7 factorial also, n minus k here 1 equals 1, so 7 minus 1 equals 6 factorial, okay, k equals 1 factorial times 0.13, 0.87, here it will be of power k equals 1, and here k equals n minus k, which will be 6, okay. The third one, 7 factorial, divided n minus k will be k equals 0, so 7 minus 0 equals 7 factorial, then k factorial, 0 factorial again, okay, 0.13, the same thing, 0.87, the same thing, okay, here of power k equals 0, n minus k 7. So calculate them on the calculator. I get the probability of all of them. So the probability of k equals 0, k equals 1, k equals 2 all together, if I add them up, the probability of these 3 will be equaling 0.09479. So the probability of k greater than 2 means anything other than this 3, because it's not equal. So 2 is including here, okay? Greater than 2 will be 1 minus this probability. 1 minus this probability. 0. Sorry, here there is no 0. Sorry, by mistake I put 0. Here 0.9, okay? So here 0.0579 equals 0.0521. Which is around 5%, okay? 5%, it is reasonable because the total population is 13%, so 5% is closer to it. But imagine that you get it 90%. The percentage for the population is 13%. How if you withdraw only 7 people, you will get the probability of 90%. Okay? So there will be 5%, which is not so far from 13%. So I hope this one is clear. The only issue here was more than 2, so you have to repeat the problem 3 times. But you have to be careful whether it is more than or equals to 2 or more than 2 only. Okay? Because here we consider 2 because it was more than 2. So more than 2 means 3, 4, 5. So 2 is not included. So 2, it has to be excluded with the 0 and with the 1. Okay? So here in this problem, it says that suppose the researcher determined that a new drug has 40% chance of preventing infection. So the probability, now we became familiar with it, probability 0.4 by certain flu strain if the drug is administered by to 8 subject, 8 people, okay, or 8 subject, okay. So n equals 8, okay. Since I get p, I can get q equals 0.6. So I close this chapter of the p and the q. What is the probability that the drug will be effective in preventing infection in exactly 6 subject people? So here k will be equaling k in the first case a. In the question number a, k will be equaling 6. So I have p, I have q, I have n, and I have k. I can calculate them. Yes, I can do. I just can write the formula here. Okay, n factorial n minus k factorial k factorial. This is NCR, the combination formula. Okay. K factorial. Okay, p of power k, q of power q, n minus k, and let us substitute here. So I have n equals 8 factorial divided n minus k, n 8 k6, so 2 factorial, k equals 6 factorial. Okay, p equals 0.4 and the q equals 0.6. So p of power what? P of power k 6 and q of power n minus k, which is 2. Okay, so by calculating this, I'll get the answer equals 0.0413, and this is the probability of having exactly 6 number of people. This answer of A. The second question is that fewer than 6 subjects. Okay, fewer than 6 subjects. So he did not say fewer or equal to. Fewer than, it will be 5, 4, 3, 2, 1, 0. So I have to calculate it 5, 4, 3, 2, 1, 0. 6 times. Okay. So I have to calculate 6 times for each k. One time k will be 5, k will be 6, k will be 7. Or I look at the total number which I have. The total number of the sample is only 8 subjects. Oh, so I can, instead of say that fewer than 6, okay, fewer than 6, I can say more than 6 or equal 6, because equals is here. So 6, 7, and 8. I can calculate only 3 times, 6, 7, and 8, and say 1 minus the probability of this 3. So I say 1 time k equals 6, k equals 7, and the k equals 8. So these are the 3 potential possibility, because 7 is greater than, more than, not fewer than, the other way around. I make the opposite. Okay, so k is more than 6. Okay, 8 is more than 6. 6 is the same as 6, but he said fewer than, so 6 is not included in the fewer, so I have to include it here when I do the other way around. Okay, so 6 will be included here, 6, 7, and 8. So I'll calculate for each one of them and add them up, sum them. Okay, and the answer will be 1 minus the sum of the probabilities which I have, in the same way which we have taken in the previous example. So here I can calculate 1 time for 6, 1 time for 7, and 1 time for 8, and add them up. Okay, and after adding them up, 1 minus the probability. So here, every time I put here, first one will be n factorial. N will not be changed in n of them. Okay, so you can put n for all of them. N will be 8. So 8 factorial, and the second one also will be 8 factorial. Here it will be 8 factorial, and here p will not be changed. P 0.4 of power, and the q 0.6 of power, 0.4 of power, 0.6 of power, 0.4 of power, 0.6 of power, and then 8 factorial divided n minus k. K in this case will be 6. So 8 minus 6 equals 2 factorial, and k factorial will be 6 factorial. Okay, 8 minus 7 equals 1 factorial, and 7 will be 7 factorial. N minus k will be 0 factorial. Okay, and k factorial 8 factorial. So here just put here the power of p. Power p, it would be always k. So k here equals, okay, this k 6, this k will be 7, k here will be 8. Okay, and here will be n minus k, n which is 8 minus k 2, n minus k 1, n minus k 0. Then have the calculation, calculate them, and then add them up. They will give us almost 0.05. Okay, the total of them. So the probability of k less than 6, this is more than 6, 7 more than or equal to 6. Okay, less than 6 will be equal to 1 minus 0.05, which will be equal to 0.95. So k, probability of k less than 6 will be equal to 0.95, which we have. Okay, he followed the same way which we have, the way I explained to you in the previous slide. So 1 minus all the sum of the probability.